All right, we're looking at system of equations and figuring those out from tables and graphs. So when we look at this here, we're looking at it as some plumbers here. You've got Jonah that has a chart here on what he earns and Otis over here. So it wants to know the charge per hour and the service fee. The service fee is just how much it costs for them to come out. And so if we're looking at the charge per hour, well, that's just our slope. So from 0 to 25 be 25 over 1. And so we'd say for Jonah that's $25 or 25 over 1, so $25 per hour. And then for Otis, from 50 to 65 would be 15, and we could check that on any other one. And from 0 to 1 is 1, so it looks like $15 per hour for Otis. Then when we talk about the service fee, really that's your y-intercept. It's the charge just for them to come out before they do anything. So Jonah here, it looks like, is a service fee of $0, so no service fee. So $0 fee. And Otis, on the other hand, it's $50 to come out and work on something. And then $15 per hour after that. So I could ask you, well, which plumber is going to be less expensive? Which one would you want to use? And looking at the charts, you'd say, well, I think I would use Jonah because all those prices at 1, 2, and 3 hours are less expensive. But we got to remember Otis is only going up $15 a time. So what if you have a job that's 10 hours or 20 hours or 30 hours? And you've got a little bit of a different deal. So let's put this on a graph and see kind of what it looks like. Looking at an equation for us here. For Jonah, we said the per hour was our slope. So it's 25x, and that would give us an equation there. $0 service fee, I could put plus 0, but again, we don't have to really put that. For Otis, y equals 15x plus 50, because he does have a service fee there. So if I'm graphing Jonah, it's at 0, then 125, 250, 375. Just going up right along the diagonal there, because these are labeled 25 at a time. If I go for Otis, now I'm starting at 50, but I only go up 15 each time. So go up to 65, then 80, 95, just somewhere around there. Gives us a decent idea of where we're going here. And so there's ours for Otis. And what we should notice, there's an important point here, right around this 125. And so when we look here, it's asking about, and this was a typo, should be the point 125. But the significance of that point, where they cross, so it's where they intersect. So it's the intersection of the lines. But more importantly, when we're thinking about the cost of these, if they're working for exactly 5 hours, that means at 5 hours, Jonah's would cost $125. Otis at 5 hours would cost $125. And so we'll say, for this situation, say at 5 hours, they cost the same amount. Okay, so, and more so even than that, they'd both be 125 there, but anything greater than 5 hours, and this is your practical part. So if you're looking for a plumber, this is your line right here. If it's going to take about 10 hours or taking anything more than 5 hours, and we say I probably want to use Otis if it's more than 5 hours, or if it's less than, that's when, because again we're looking at, we want the least price, then I probably want to use Jonah if it's going that way. Just looking at it practically, because Jonah's down here for this one, and then Otis going on forward is less than Jonah. So definitely doesn't work out that simply every time you're looking at pricing something, but you can get at least a good idea on that of what you're doing. Okay, so the rest of these we don't really have a word problem to go with, but what we're doing is looking at, can we get the equations from the table and really just at least build a system of equations there. So for these, just a little review of what we're doing. I'm going to do change in y over change in x. So if I go from negative 15 to negative 11 here, and we're just finding the equation, that would be going up plus 4. This is plus 2. So a slope here would be 4 over 2, or just 2. And then my y-intercept, if I go up 1 here, there should be a 0 there somewhere. And that means I'd go up 2 here, negative 3. And again, just shortcutting that, kind of reasoning through finding each part of this. So my equation, I get y equals 2x minus 3. And of course, when you've got a table, we can also put it in Desmos and use that to get our equation as well. The other way that I would do this is just say, here's a point, x1, y1, x2, y2. Those are 2 points that are on my table, and I could just do for slope equals y2, so 5 minus y1, which is 6, over negative 3 minus negative 6. And remember, when it's minus negative 6, we just do plus 6. So 6, 5, 4, 3, that'd be 3, and that would be a negative 1. So my slope is negative 1/3. And then I could reason through and find my intercept there, or if I needed to do point slope form, I'd probably use the 0.33 and do y minus 3 equals negative 1/3 x minus 3. And multiply it out, we get plus 1, negative 1/3 x plus 1 Then it's minus 3, so I add 3, and I get plus 4. So that gives me y equals negative 1/3 x plus 4. Okay, all just going through some different ways that we have to find those two equations. And once we've done that, it doesn't ask us to find the point where they intersect. We're just leaving it as is. So we've got our equations there, and we are good to go. Okay, the next one, it asks for it in standard form. Not going to go through all the steps that we do for that, but if I worked through it, we'd get a slope of negative 3 here, y-intercept of 2. In standard form, it ends up as 3x plus y equals 2. And on my second line, similar thing, I'd get a slope of positive 4 and a y-intercept of negative 4. And so we end up with y equals 4x minus 4. When I change that to standard, move the x back over and change it to positive, so I end up with 4x minus y equals 4 for our standard form. Okay, last thing we'll look at here is when we've got graphs. And so when we've got these graphs, just writing the system of equations is just finding, there's my y-intercept and what's my slope. Looks like I've got a perfect point there. I'll confirm it with one more. So I go up 2 to the right 1, it's a positive slope. So y equals 2x plus 5. And for my second one, negative 3. So I can go ahead and put a minus 3 at the end there. That helps. And my slope, I'll find perfect point there and there. I always find a couple points, that way they're the same distance apart. This one goes down 2 to the right 1. So negative 2x minus 3. Gets us that there. And so just as quick as looking at those and writing that, I should be able to be getting those pretty quickly as we move along. Then writing system of equations in standard form. When we get the equations, this one's y equals 1/3 x plus 2. And so remember our steps to change that to standard form. We'll multiply everything by the denominator of 3, because multiplying 1/3 times 3 gets me just 1. 3y equals 1x plus, and times all 3 parts, plus 6. Then I move the x, which changes it to negative, so I move it, it changes signs, negative 1x plus 3y equals 6. So to get the final standard form, multiply everything again by negative 1 to get a positive x, a negative 3y, and a negative 6. Do the same thing for the other one. Got a negative 1 down there as my y-intercept. And my slope, find some perfect points there. So look like we're down 3 to the right 2. So negative 3 over 2x. And all we do there would be, let's multiply by 2 to give me 2y equals negative 3x minus 2. And then when I move that x over, it turns positive, and so I just have 3x plus 2y equals negative 2. Right, so that's a pretty quick overview of that. We'll go over that some more as we move along, but that gives you an idea of how we write those systems using a couple different methods.